Look, guys, I'm going to draw in quadrant 1 for A, which is 3 and 5, you see, which is so much better. Hurrah.
I didn't understand anything.
This is A. This is the nice one. If one of the side lengths is 3 and the radius is 5, the other one's always 4. 3, 4, 5. It's a really nice one. It pops up every so often. It makes your heart sing. So, y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. Square root, and you get plus or minus. In this case, it's plus 4. So, minus sine A is 4 over 5. I think the side length in B is going to be 12. Just guessing. I'm not smart. 3 pi over, between 3 pi and 2 pi, so it's going to be negative 12. 5, 13. Because you're going to go y squared equals 13 squared minus 5 squared. Y squared equals 169 minus 25. Y squared equals 144 plus or minus, and in this case it's negative. So if you didn't want to draw the triangles because you can actually visualize where that is and you know that's a negative y, that's fine. But you need to know to check for your signs, right? Because when you do the square root of anything, it's plus or minus. So this one's going to be negative 12 over 13. And then you just do them together. 3 times 5 is 15 over 13 times 5, which is 65. Plus, it's going to be negative 4 times negative 12, which is 48 over 65. So you get 63 over 65. And that's the exact value of cos A plus B. So where do people error instantly? They take this 3/5 and they put it in for A. They take the 5/13, put in for B, and they find cos of that. That's one error. Or they just add the two of them. That's another error. Those will be answers on your diploma, those errors. So whenever you see this, you have to think, hey, I can expand that out. Because when I expand that out, I have cos A and cos B, which I already have answers to. I just need to get sine A and sine B.
Well, that's just the final answer. You're done.
Yes.
After that trig thing, I'm always expecting something.
After the tan one.
You're done. You're done.
So these are the formulas that are the double angle identities, and they're on your formula sheet. They're the last ones. It says evaluate the following using a double angle identity. So I need to use cos 2A, 2A, 2A. So what would A have to be in order for 120 to be the answer? What would A have to be in order for 120 to be the answer? If you're doing 2 times something. 60. So we're going to go cos 2 times 60 degrees. Now remember I told you we labeled the A's and B's when we did addition and subtraction, right? Same thing here. A in this case is just the 60 because it's 2A, right? So 60 is going to go in for every A. Doesn't matter which of the 3 formulas we use up top because there's 3 for cos. No. When we're solving, when we're proving trig identities, then it will matter. But for this, you can pick whichever one you want. So I'm going to do the bottom one. So I'm going to fill it in for 1 minus 2 sine squared A. So I'm going to go 1 minus 2 sine squared 60. Which is the same as 1 minus 2 sine 60 squared. Which is 1 minus 2. Sine of 60 is root 3 over 2 squared. So I'm going to get 1 minus 2. And then root 3 squared is 3. 2 squared is 4. So we're going to get 2 times 3 over 4. So it equals 1 minus 6 over 4. And 1 is the same as 4 over 4. So I'm going to change into that. 4 over 4. So I get negative 2 over 4, or negative a half. Which makes sense, because cos of 120 off the unit circle is negative a half, right? They're just forcing you to show you that you can do it with the double angle identity. We're going to look at example 2. It's spotting the double angle identities that's hard to do because everyone doesn't remember what the formulas look like because we don't use them a whole ton, but we do use them sometimes. So 6 sine pi over 10 cos pi over 10. People are like, that's fantastic, except there's no formulas that are 6 sine x cos x, right? Because these are the exact same. There is a formula, though, for sine. Sine 2x equals 2 sine x cos x, right? The catch of the x have to be the same, which they are. Is there any way I can turn that 6 into a 2? What times 2 is 6? 3. So I could change this 6 into a 3 times 2. So we'd have 3 times 2 sine pi over 10 cos pi over 10. Right? The 3 would stay a 3. This 2 sine this cos this turns into what? What does this all turn into? That. Right? So it's actually going to become sine 2 what? Sine 2 times pi over 10. So you're going to get 3 sine pi over 5. Just wants you to write it as a single trig function. When we look at this one, 1 minus 2 sine squared pi over 8, is there any formulas that use that? Yes, the cos 2x. So we have a cos 2x formula that equals 1 minus 2 sine squared x. So this whole thing can be replaced with cos 2x. But what's in the x spot? Pi over 8. So we're going to get cos 2 times pi over 8, which is cos pi over 4. That's it. It doesn't want you to solve it. It just says write as a single trig ratio. Done. And this one, people will sit forever and be like, oh, I don't know how to do this. How do I do this? And they try and change it into all these crazy things like sines and coses, which you'll do once you learn proofs. This is the double angle trig identity, or tan identity. That's it. So tan 2 theta equals 2 tan theta over 1 minus tan squared theta. So this whole thing can be replaced with tan 2 What's theta? Pi over 3. So this whole thing is the same as tan 2 pi over 3. So it's not hard to do. You just have to spot it. So you see why I said the people who know what's on their formula sheet do a heck of a lot better than the people who just look at their formula sheet. And because you won't even spot this. You'll instantly start changing these to sines and coses once we start doing proofs. I promise you, you will. But if you know your formula sheet well, you'll be like, wait, I've seen that somewhere. Where did I see that? Oh, that's the double angle tan identity. Okay? Yeah.
Please copy that last one down. Please.
What are you writing?
That. I'm very fast writer. And then almost done.
If there's 2 lines.
I know, but I have to write down the whole equation. I
Um,
forgot to copy the notes. I don't know if you did that yet. I didn't copy the notes, so I had to write down all the equations.
all right.
It's just a mess, you know?
So if I give you something like this, cos x equals negative a third, okay? And you see sine 2x. What's the thing you should do when you see sine 2x? Write out the formula, which is 2 sine x cos x. I'm given cos x, which is awesome. So I can fill that in and keep the 2. Cos x is negative a third. But what am I missing? Sine. How do I get it? It's y over r. This is x over r. Oops. And we're in quadrant 2. So it's negative 1, 3. So I'm going to do 3 squared minus negative 1 squared y squared. So y squared equals 9 minus 8, or 9 minus 1, sorry. So y squared equals 8. So y equals plus or minus root 8. And in this case, because it's in this quadrant, it's positive. And root 8 you're going to reduce. Root 8 is what? 2 root 2. Because you can break root 8 into root 4 and root 2, right? Which is 2 root 2. So you're going to get y equals positive 2 root 2. Okay. So here you're going to get 2 root 2 over 3. And this would be 2 over 1. So you're going to get 2 times 2 root 2 times negative 1, which is actually negative 2 times 2 times negative 1 is negative 4 root 2, all over 1 times 3, which is 9. That's as good as it gets. Then the same would go for cos 2x and tan 2x, would be the same thing. Now this one here, example 4, consider the expression sine 2x cos 2x plus 1. Here they're going to say consider the simplify the expression to one of the 3 primary trig ratios. To one of the 3 primary trig ratios. So sine 2x I can replace with 2 sine x cos x. That's my only option, right? So I always replace the sine x's, the tans, whatever first before the cos 2x's. The reason why I replace the cos 2x last is I have 3 options. So I want to replace everything else and then figure out which option would be best for me to replace the cos 2x with. So sine 2x is 2 sine x cos x. It wants one of the 3 primary trig ratios. So I need to either get the sine or the cos to go away. Well, I have cos 2x plus 1, okay? All of my cos 2x's were replaced with either cos squared x minus sine squared x, or 2 cos squared x minus 1, or 1 minus 2 sine squared x. I can tell you which one I'm going to pick right off the bat. I have a plus 1 sitting at the back. I need it to go away, because I can only cancel something off the top and off the bottom if it's just like a sine x or a cos x. If I had a sine x or a cos x on the bottom, or just a sine squared x or just a cos squared x on the bottom, then I could cross off a sine or a cos, correct? But with this plus 1 at the back, I'm kind of sitting stuck. So I'm not going to use the first formula over here, which is the cos squared x minus sine squared x, because it doesn't have a 1. So my 2 options are these ones. Okay? If I replace it with this one here, with the bottom one, with the 1 minus 2 sine squared x, the 1's don't cancel. I actually end up with a 2. 1 plus 1, I get 2, right? That's not going to be helpful. If I use this one, which is 2 cos squared x minus 1, that one will be helpful, because I'm going to have a minus 1. I have a plus 1 at the back, and what are they going to do? Cancel. So that's why I always say write the top out and then do educated. If you don't have an educated guess, you could work through all 3 and see which one. You'd have to do trial and error to figure out which one works best. So I'm going to replace the cos 2x with 2 cos squared x minus 1, because I have a plus 1 at the back. If I had a minus 1 at the back, then I would have replaced it with the other one, and they would have canceled, right? So now these 2 cancel. And I'm left with 2 sine x cos x over 2 cos squared x. Cos squared x is just like cos x, right? So this one cancels off that one. This cancels off this. And some people will say, but now I'm left with sine x and cos x, and that is not a primary trig ratio. Yeah, it is. What's sine x over cos x? Tan. Write this one down. You're going to do it for your homework, and we're going to go through it tomorrow. And then I'm going to assign you the other. Don't do all of that. I'm going to assign you the other part of this homework. So write that question down. You're going to do it for homework. We're going to go through it tomorrow. Then page 306. For ABC, number 5. Yep. 7 is just one question. 10. 11. 17 and 20. 17 and 20. 20. 20 is that one where you get the A and the B, and then people have to actually remember to fill it into the formula. I want 20, not BC. I want 20.